Good morning, everyone. Welcome to lecture 6 of problem solving and computer programming course. So, in the last 5 classes, we have discussed about basic of C++, including the computer systems with its component. But in today's class onwards, we will discuss the internal details of internal things about C++, like we are going to discuss about variables and constants and how you are going to assign a value to a particular variable. That is nothing but assignments. Next, we are going to see more detail about input and output operation. Although you are familiar with C in and C out, right? We are going to see much details about it, right? Then we are going to see various data types and expressions. I'll tell you about a couple of data types, like you already know about few data types like int and double, right? Show some other data type also we are going to see in this section. Then we are going to discuss the flow control, like I'll introduce about if statement here, okay, switch case statement here. Then we will see some of the programming style, right? But in today's class, we will go for variables and assignment, and subsequent classes we will go for these input, output, and data types and expression, simple flow control, and program style. So come to the variables and assignment. So what is a variable? So variable is something like you can say it is a blackboard, right? Suppose somebody is writing in the blackboard about a variable. Let's say I am giving a variable name as a, right? So if I'll ask you, a is a variable, what is the value? Somebody may say 5, somebody may say 6, somebody may say 10, somebody may say 20. So the value varies with respect to the person, right? But at the same time, if I write a value 5 in the board and I'll ask you what is the value, all of you will say 5, right? So what is the difference you have seen in this two examples? In the first example, you are writing a variable which may hold any value, right? The value may be 5, may 10, may 20. With respect to the person, the value may vary, right? But second case, I am specifying a constant. The constant is common for all because that value will not be changed. So here if you see, the variables are like our small blackboards. So where we can write a number on them, okay? We can change the number, we can erase the number. For example, I asked the first person, what is the value of A? He told 5. So I am writing A is equal to 5. I asked the second person, what is the value? He is saying 10. So I erase 5 and I am writing 10. I asked third person, what is the value? He is saying 35. So I am erasing it and writing 35. So you can write, you can change, you can erase the number from the board. That's why the value A is called as variable. The value of A is variable. For example, whenever you are writing the program, maybe in the line number 5, let me write line number 5, you have declared A is equal to 10. Okay, maybe after some time, let's say in line number 15, you are writing A value as 35. That's possible, right? The value is changed, right? But whenever we are talking about a constant, the value is fixed throughout our program execution. So generally, whenever you go for memory allocation, right, computer memory allocation, each and every memory location is located with a name, right? Because if I say each and every memory location by a binary value of, let's say, 32-bit or 64-bit, you may not understand. And remembering that is also very difficult. That's why what we are doing, C++ variables are the names for memory locations. Whatever memory location is there, they are represented in the form of a name so that user can easily remember that particular name, right? But if I'll tell a 32-bit binary number, or you can say 64-bit binary number, so it is very difficult to remember, right? Although you have octal number system, hexadecimal system is there to represent the same, but the main thing is it is very difficult, right? So what we can do here, we can write a value in them, right? If a memory location is allotted to you, you can write a particular value in them. For example, you see this is, let's say, our computer memory, right? In which in this particular location you want to save the value of a, right? So earlier it is represented as 5. Okay, so 5 can be represented as 101, right? If you follow a particular BCD coding, right? Binary coded decimal. So 5 is generally represented in the form of 1. So you require that the decimal to binary conversion. If you convert the value in the decimal, that is in 5, if you convert, you are going to get 101 in the binary, right? And you can store this into the computer application, right? For later point of time, if you want to save the value as 10, then in the decimal system, which is represented as 1010 in the binary, right? So if this location is capable to store a uh, big number like 32-bit number, then you can pad extra zeros in front of that, right? And subsequently, whenever you are changing the value is 5 to 10, so what you have to do, you have to replace this one with 1010, and it is preceded by number of zeros, right? So we can write there, we can change the value stored there, and we cannot erase the memory locations. For location we cannot erase, but the value we can erase. Sometimes
voice is not clear, sir.
Now it is audible.
Sir, clear, but when you wrote something, we get beeps.
Okay, okay. So what I am saying that if you go for a computer memory location, right, we can write a value into that location. We can change the value stored in that particular location, and we can erase the location as well, erase the value of that particular location, but we cannot erase the memory location, right? So sometimes what happens, whenever we are declaring a particular variable and we are assigning a value to that particular variable, later point of time we are not erasing it, right? So some values are always there, right? Whenever you want to print a value, for example, I want to write int a, then without writing a is equal to 5, okay, I am assigning a is equal to 5, but this statement is, let's say, it is not available, then I want to print the value of a, right? I am writing c out a. So what will happen? So here the value you have declared here, but you have not initialized it. So here you can see some values will be there in that particular location where a is allotted, right? A is allotted to, let's say, this particular memory location. Okay. So in that location, some value is earlier there, like this 101010, something is there. So that value will be written, which is an incorrect value, right? So we cannot erase the memory location, but we can change the value of this particular location. And if you are not assigning some proper value, then it is printing some value what is available there, which we call as a garbage value, right? Some garbage value is coming, which is not the exact value, right? Okay, but in the constant case, the value is same for all. So that constant will be applicable whenever you want to multiply, like you are saying you are multiplying something with 3.14, or you want to some multiply some variable by 5, something that in that case we are declaring, right, constant, right? Okay, so you can see this is, there is a program, right? In this program you are given with 3 inputs. You can see you are given with 3 inputs. One is nothing but number of bars, right? 3 input. One is nothing but number of bars, right? Second one is nothing but weight, which we call as one weight. Third one we have total weight, right? Total weight, right? Okay. So what actually we are doing, actually 2 input, not 3 input. We are giving 2 input, but we are declaring 3 variables. This is not the third input. We are giving input as number of bars. Still my voice is not clear. Can anybody respond?
But when you wrote something, we get annoying beeps.
Okay. So let me rejoin again, right? Please give me 1
Usually
minute.
also, usually also your words are not clear, sir.
My voice is clear now?
It's a clear.
Okay. Now, are you getting my voice clear? So
No,
whenever
sir.
you write,
No, sir.
whenever
Again, beeps are coming, sir.
When you wrote beeps coming.
okay, otherwise I'll not write anything. Okay. So just
Sir, once
continue
go to
writing.
settings and change, sir, that sound. There will be a tap sound.
No. I the setting. Which setting you want to change? Can you please tell? Okay, let it be. No problem. Okay, I'll not write anything. Okay, in see this program. In this program, you have even with the volume is high only. Now still you are not getting my voice clear. My voice is clear now, right?
Voice is clear.
Okay, that's fine.
It's clear now, sir.
Okay. You can see here that we are declaring three variables. One is your number of bars, right? Another is one weight, another is two weight. And we have used for the first variable, we have used the data type as integer, right? For the next two variables, we have given the data type as double. I will tell you what is integer in double whenever we discuss about the data type. So what we are giving? We are giving the two input here. One is the number of bars. Okay. Another is we are giving input as one weight. Right. You can see there is a candy bars are there. I am calculating the weight of each candy bar. Okay. That is we are representing in the form of one weight. And you know that if you want to calculate the total weight, what you have to do? You have to multiply the number of bars you have with the weight, right? By assuming that all the bars are having same weight, right? So if you multiply like that, then you can get the total weight. For that, you have to write the program. So you know that program always starts from the int main, that is main function, right? Whose return type here we have mentioned as int. Int as you are writing at the last statement, you can see we are writing return 0, right? You can see for integer main we are writing return 0. If you write void main, then return 0 is not required because void is a non-return type, right? So I have declared the variable here, right? And you know how to ask input to the user. So I have displayed a message that is enter the number of candy bar in a package or in a box. How many candy bars are there? Then I am asking and the weight in ounce of one candy bar. I am calculating. I am asking the one candy bar's weight. Then press return. So these three messages I am displaying in the output screen. So you can see first message, at the end of the first message, you have /n. So in the computer screen, first it will come, enter the number of candy bars in a package. Then there is a /n, so it will go to the next line. then it is going to print and the weight of ounce of one candy bar, full stop. Then there is a slash n, so it will come to the next line, then it will print, then press return, full stop, then slash n. So in the fourth line, it is asking you to input. One, you have to provide the number of bars, another you are providing each and every weight of a particular bar. So here what you can do, you have to specify the number of bars. For example, number of bars is here, let's say 10, right? And one weight is, let's say, one weight of a particular bar is, let's say, 5. The number of bars you have 10 in a particular package, like you can see here, there is 2 bar, and individual weight of the bar is, let's say, 5, right? In some weight unit. Then you are going to calculate total weight is equal to one weight, that is 5, what user has given input, multiplied by number of bars. Number of bars is here, let's say you have given input as 10. So it will multiply 5 with 10 and it will save the value in the total weight, right? Now what you have to display, you have to display what is the number of bars the user has given input, and you have to also display the input with respect to one underscore weight, and whatever you have calculated, that is total underscore weight, also you need to display. So you can see here in the output, we are getting C out number of bars is equal to candy bar, right? Number of bars is nothing but, in this case, number of bars is 10. So it will display 10 candy bars. Then there is a slash n, so it will go to the next line. It is going to print one weight we have taken as 5. So 5 ounce each. Then it is showing total weight is, total weight it will print, total weight is nothing but this 5 into 10 is 50. Okay, 50 ounces, right? Then after printing this one, then there is a slash n, so it will go to the next line. It is going to print another message, that is try another brand, full stop. It will come to the next line. Enter the number of candy bars in a package. Then there is a slash n, it will come to the next line. The weight in ounce of on candy bar dot. So it will print this statement, then followed by slash n, so it will come to the next line. Then press return. So it will print this statement, then there is a slash n, so it will come to the next line, and it will expect 2 input. One is your number of bars. For example, here you are writing number of bars as 20 and one weight is, let's say, 5. So it will calculate 5 into 20, which you are going to get total weight as a 100, right? Again, it is displaying in the similar fashion what you have printed here. That is number of bars in the candy bar is 20. One weight is nothing but 5. Okay, that is 5 ounces each. Number of bars is nothing but 10 candy bars, 5 ounce each, and total weight is nothing but your 20 into 5 is 100 ounces, right? Then you are displaying a message, perhaps an apple would be healthier, right? This message it will print and it will stop execution. So you can see in this program, what is main important point you should know for this particular program is that you are repeating couple of statements 2 times. You can see almost starting from this C out to this C out, right? Calculation of total weight. The same thing you are writing here, right? Which tells you that why not, if the same code we want to execute multiple times, why not use some kind of new mechanism, which we call in C++ as a loop, right? You are going to repeat the same statement multiple times. For example, if I tell you take 5 inputs, 5 times input. So what you can do, you can repeat this code 5 times, which is not good, right? So what you need a concept of loop, so that you can repeat the process without repeating the code, right? You need not repeat the same process multiple times. You need not write the same code multiple times, but the same code can be referred with different input in the C and C++ using the concept of loop, right? So if you want to see the output of this one, you can see the output. They have given as input as 11 and 2.1, where 11 is nothing but your number of bars and 2.1 is represent your one weight. So 11 multiplied by 2.1 is 23.1. So it is displaying total weight is 23.1, right? Similarly, you can see in the bottom part also you are asking another input. So it is giving number of bars as 12 and one weight is 1.8. So it is calculating total weight is 12 into 1.8. So it is coming 21.6. And finally, it is displaying one message that is perhaps an apple would be a healthier, right? Then it will complete its execution. So you can see the use of slash n here also, right? You after writing each and every statement, you are writing slash n. So it is coming to the next line and printing the statement. So you have to be very careful that when to use slash t, when to use slash n, this escape sequence you have to write in order to properly print the your output in the output screen, right? Now let us see in this case, if you see variables names are called as identifier. How to decide which one can be a variable, which one cannot be used as a variable, right? So variables names are called as your identifier. In order to choose the variable names, what you have to do, you have to choose a meaningful names. Okay, you have to write the variable name in such a manner that if you are giving your code to your friend for decoding, for advancement, for anything, your friend can understand what you have written, right? Generally, in many cases, we are using, if I will ask you to write a code for addition of two number program, you are writing A, B, and C, where A, B is input, C is your output. But such variable declaration is not a good practice. So what you can do, you have to write the code in such a manner that other people can understand. So as you are going to join software industry, many people will go software industry after completing the degree. So you have to be habituated of writing, declaring a variable. So you can write first underscore number. Instead of writing A, you can write first underscore number. Or number is sometimes represented in short as a NO, right? NO. That is not no. NO indicates number. Similarly, second number, you can write second underscore NO, right? And third number, you can write third underscore NO. If such a declaration will do, then it is more meaningful than writing A, comma, B, comma, C and semicolon, right? So use meaningful names that represent the data to be stored. And in order to choose a variable name, you have to ensure that the first one should be a letter, right? Or it may be an underscore character. For example, you can declare a variable whose name is underscore NIT, or you can declare a variable NIT on NIT without writing underscore. You can write NIT. Both are valid. First case, you are using a letter. The first one is a letter followed by anything. Second case, we are writing underscore NIT means underscore is the first character. So first character must be a letter or it is a underscore. But what about the rest letter? The rest letter may be it may be a rest character in the variable name, maybe a letter, maybe a number, maybe underscore character. Like I told you, I am writing first underscore number. F is the first letter, so it is a letter, right? It is an alphabet, so it is allowed. Suppose you are writing second underscore number. S is a variable. Sorry, the first letter of the variable is S, right? So it is allowed. Suppose somebody is writing underscore XYZ, right? Underscore is the first character. It is allowed. Somebody is writing underscore 001. It is also allowed because first one is underscore. So that is allowed. The rest character can be letter, number, and underscore. But it is a good practice that people are using only letter in the first character. First character we are writing letter. In fact, underscore is allowed, but people are not using because there are some system calls are there. There are some system functionalities there which is also starting with this underscore. That's why maximum people are writing first character of the variable is a letter only, right? So it is a good practice to use first letter as letter, but not necessary. you can use underscore as well. Now come to the keyword. Keywords are called as your reserved word. If you go for C programming, you can list 32 keywords, and these are called as reserved words. And these keywords, the name of the keyword should not be used as a variable name. For example, you have seen int stands for your integer. It is a keyword or a reserved word. So you cannot declare a variable like double int. That is not allowed, because double is your data type, but int you are treating as a variable name, which is wrong. So you have to ensure that these reserved words or keywords should not be used as a variable name, right? So keywords are used in the C++ language. Most of the keywords, okay, is same as C. Like C is having 32 keywords. Almost all the keywords are used in the case of C++. So keywords must be used as they are defined in the programming language, but it cannot be used as an identifier, right? You should not use as a identifier, otherwise you will get an error, because these words are having special meaning. Like whenever you are writing int, so it indicates you are going to deal something with integer. So whenever you are writing double, it indicates that you are going to do with something with a double number, which is nothing but a floating point number, right? A big number, right? With the decimal point, right? So such type of instructions we are providing. That's why you should not use these words as your identifier, right? Or a variable name. Now you can see here, in order to declare a variable, before use, variable must be declared. Suppose you want to write a statement, like in that program we have used a statement, total underscore weight is equal to 1 underscore weight multiplied by number of bars. Number underscore of underscore bars. We have written that statement. So here we have used three variables. One is the total weight, another is one weight, another one is your number of bars. Three things you have used. So before writing this statement, that is total underscore weight is equal to 1 underscore weight multiplied by number underscore bars, you should declare it. So if you declare it, it tells the compiler the type of data to store. What kind of data you are going to store in computer memory, that will be decided. And the size of declaration also varies. For example, you see in this case, I have declared int number of bars. In the second line, I have written double 1 underscore weight and total weight. If you see in these two statements, first statement, you are declaring an integer variable, that means number underscore of underscore bar is an integer variable, but second case 1 underscore weight and total underscore weight is a double variable, right? And the memory allocated to an integer variable is different from the memory allocated for a double variable, right? The size of integer is different from the size of double, right? So accordingly, the memory is allocated for these variables, right? For example, if you want to write int, if you want to declare an integer, like you have declared your int number of bars, so what could be the value? The value may be your 3, value may be 102, value may be 3211, value may be minus 456. So apart from this int double, we have another data type that is called as float. Okay, but if you see if you compare float with double, then float can store a number which is having limited space. I will tell you what is the size of each and every data type. For example, float can store some location up to some location. For example, you want to write a 2.5 something like that, then that can be stored as a floating point number. But if you want to write a big number, big real number, for that the float is not sufficient, because the memory occupied by float is not sufficient to store that number. So what is the alternative? You have to go for double. where double can store more, double can occupy more space, so that a big real number you can store, right? So you can see if you are going for int, what could be the value? The value you can store into number underscore of underscore bar, maybe 3, maybe 102, maybe 3211, maybe minus 456. So like that you can store the value inside this number of bars. Whatever memory is allocated to number of underscore bar, in that you can store like that, right? And you can see your number of underscore bar is a variable which is of integer type, right? Similarly, you have seen that one weight and total weight are both of double type. The data type of these two things is double type. So what can be said they can store? They can store 1.34, they can store 4.0, they can store minus 345.6. Any value they can store. Although these values can also be stored as a floating point number, right? Because these values are not that much big, so that float cannot accommodate. These values are very small, so float can easily accommodate. But double can give more space to you. That's why here they have written double. So it may happen that user can enter a very big number, which is not the capacity of a floating point in data type to capture that particular value, right? Now you can declare the variable in two locations. One is, you can see in the first program, I have started the main function, then I am writing int sum. So sum is an integer type. Score 1, score 2 is already declared. Let it be a integer, right? Score 1 and score 2 is also integer. So what you are doing, you are adding score 1 plus score 2, then you are writing sum. But in this case, they have not explicitly shown the declaration of score 1 and score 2 and assignment of value of score 1 and score 2. We assume that is available, right? So you can declare in this particular location, or sometimes you can declare above the main functions also, right? That is at the beginning, okay, just after your header file or using namespace std, you can declare a variable as well. If you declare at the beginning before the main functions, sometimes we call that as a global variable. Okay, global variable means in a particular program you may have multiple functions. Like you can see here, there is a main function. Similar type, there are other functions are also there. Like I can write something as add function, there is a subtract function, there is a division function, there is a multiplication function. So there are many functions are possible, right? So sometimes what happens, the data which is required to the main function, okay, it is also maybe required to some other functions as well. That's why what we are doing, in order to give a common value to all the functions, we are declaring the variable at the beginning of the program, that is above the main function or below using namespace std. So that is one type of declaration which we call as a global variable, or you can write inside a particular block, like you have seen in this case, int inside the int main, that is main function, we are writing int sum. So this sum, life period of this sum or validity of this sum is restricted to this block only. The value of the sum will not be same in another function. You may declare again a sum function and the value of the sum may be different from the main function. That is possible, right? So each and every function may declare the same variable and they can keep their own values. That is also possible, right? But if you want to supply the same value, then you can declare at the beginning. That we call it a global variable. If you are writing within the function, then we are called it a local variable. Local variable has less scope than the global variable. Now, if you want to declare a particular variable, you can write int a semicolon, then you can write int b semicolon, or you can combine int a comma b semicolon. Like you can see in the first case, here if you see the first case, we are writing int number underscore of underscore bars, right? Second statement, we are combining two variables. We are writing one underscore weight, total underscore weight, and its data type is double. So this statement you can write double one underscore weight semicolon, double total underscore weight semicolon. That is same. But it is a better practice that you have to write all the variables of the similar data type in the same statement, right? Obviously, double provides us more space than the floating point number. Okay, so next is if you go for the declaration, some other declarations you can see here. I have declared double, average, comma, m underscore score, total underscore score. So in this case, average, m score, total scores are the different variables, but all are double type, right? Similarly, double moon underscore distance is a double variable. Int age, comma, num underscore student. So in this case, age and number of num underscore student are two integer variables. Third case, last case, int cars underscore weight. So your cars underscore weight, your weighting is a integer, right? So in this way, you can declare variables, one variable per line, or you can merge 2-3 variables by separating with comma, right? Now, if you see the example, what we discussed, the program, that is the candy bar program, an assignment statement changes the value of a variable. Like we are writing total underscore weight is equal to 1 underscore weight plus number underscore of underscore bars. So it should be multiplied. Okay, it is not plus, it is a multiplication symbol, right? So multiplication symbol, right? So here by mistakenly they have written plus, right? So what we are doing, we are multiplying the weight of a single candy bar with number of bars in order to calculate the total weight, right? We are multiplying two things in order to get the third thing. But total underscore weight value is not assigned. Sometimes what happen, we need to assign this some dummy value. Like I can write, in this case I can write, if you see it is a double number, like you can say double total underscore weight. So I am declaring that total underscore weight is equal to 0.0. That is possible. Total underscore weight is 0.0 is possible, right? So, but whenever you are writing total underscore weight is equal to 1 underscore weight, okay, multiplied by number of bars, so the value of the total weight is now changed. Earlier it is 0.0, but now it is changed to the updated value. Like for example, I told you one weight is our let's say 5 and number of bars is 10. So I can multiply 5 with 10, so I will get 50, right? So that is possible, right? Similarly, in order to do this, what you can do, you have to use an assignment operator. Assignment operator is nothing but our equal to, or the entire statement is called as assignment statement, right? So, okay, at the end of the assignment statement, you should have semicolon. Most of the statements we have semicolon, except the statement which starts with your S1, right? Okay, so next one is the single variable to be changed is always on the left of the assignment operator. The total underscore weight is going to be changed, right? Like in the program also you have seen the total underscore weight is changed twice, right? 2 times. You have repeated the same code twice. So total underscore weight is repeated. You have repeated the code same twice. So total underscore weight value is updated twice. You may initialize with 0.0, but later point of time this value is changed, right? And on the right of the assignment operator, you can write like here I am writing age is equal to 21. So age is a variable, but I am assigning a constant to that particular variable. Like I am writing age is equal to 21 means the value 21 is going to be assigned to the variable age, right? Similarly, variables, in the case you can assign one variable to another variable. Like I am writing my underscore cost is equal to your underscore cost, means whatever the value is there in your underscore cost, that should be assigned to my underscore cost. So it should not be a variable should be assigned with a constant. It should be assigned with another variable as well, right? So you can see here in this case, your cost, your underscore cost, some value is there, that value is given to my underscore cost. Similarly, you can see expression that is circumference is equal to diameter into 3.14159. So 3.14159 is what? It is a constant. Diameter is what? It is a variable. It is holding some value. So we will multiply diameter with 3.14159. Whatever the result will come, that will be stored in the circumference, right? Now, this equal to operator in C++ is not an equal sign, what you have seen in the algebra, right? So the following statement cannot be true in the algebra, like number of bars is equal to number of bars plus 3. So it is saying, what you can see, what is the new thing in this particular statement? You are using the same variable in the left side and say the same variable in the right side. Both left side and right side is having the same variable, that is number of bars. What is the meaning? Just like you want to go for t iteration, okay, you want to calculate for t iteration and you know the value of t minus 1 iteration, right? In order to carry out the next iteration, you need the value of the current iteration, right? So here you can see whatever the old value of number of bars is there, that you have to retrieve, you have to add with 3 and you have to declare this is your new value, right? For example, number of bars is 5, so I will write 5 plus 3 is equal to 8. Now number of bars is updated to 8. Then in the next iteration, what will happen? Number of bars is now 8. So 8 plus 3, it will go as 11, right? Next iteration, it will go 11 plus 3 is 14, 14 plus 3 is 17. Like that, this process will continue. But not necessary, you are going to take a different variable. Okay, different variable in the left side as well in the right side, right? You can use the same variable. Sometimes we are writing the code. At that time, we require the same variable to update in various iterations. So in that case, we are writing number underscore of underscore bars is equal to number underscore bars, number underscore of underscore bars plus 3. So in C++, it means the new value of number of bars is the previous value of number of bars plus 3, right? Now, declaring a variable does not give its value. Like you are writing int, let's say x, int x or int a, right? So you are declaring a variable, but you have not assigned a particular value that particular variable. So giving a variable its first value is called as initializing the variable, right? You are declared a variable and you are going to assign a specific value that to that particular variable. Like you can see here, double MPG. So MPG is a variable, right? So here you can see in MPG variable, we have not written anything, underscore we have not used. Somebody may write double underscore MPG, that is also allowed. Somebody may write double M underscore P underscore G, that is also allowed, right? So based upon the names, you can declare your variable, but you have to ensure that first one should be a letter or first one should be a underscore, right? So here you can see I have declared a variable that is double MPG, but till now MPG value is not initialized, right? So if you print the value of MPG, so sometimes you are going to get a garbage value which is nowhere related to your program. So you have to ensure that after declaration of a variable, you have to initialize it. So you can write MPG is equal to 26.3. So now you are giving a value 26.3 to MPG, right? You can also declare float here, there is no problem, right? So declaration and initialization can be combined also, right? Like you can see double MPG is equal to 26.3. So what you are doing here, you are declaring a variable, MPG and 26.3 you are assigning to the MPG, right? So both things, you are declaring a variable and you are initializing. Similarly, you are taking another variable that is area, right? In case of area, you are initializing the variable as 0.0. So we are writing double area is equal to 0.0. But if you see in the third case, that is volume, okay,